Hello, welcome and good evening. Today we're going to be starting pretty earlier today. Like I said to us in our WhatsApp groups there, I have a church program today, so I will not be changed by 6 o'clock, and that's why we are starting today's class pretty early. So we have 30 minutes from us, 30 minutes for the other subjects, so that I can be able to do what I plan today. I hope you bear with me. Those of us that are not able to join now, the video I'll be able to share the video on the WhatsApp group so that they can look at the video and do the assignment that I'm going to be giving. Okay. So the person on Techno CH, can you confirm that you can hear me very well before I start?
Yes, I can hear you. I can hear you, sir.
Okay, so let's start immediately. Today we're going to be looking at mathematics and we're going to be looking at indices. And this is the platform that we're using, the very fast and effective platform, educateafricans.com. Just go to your browser, type educate. If you're using Google Chrome or any browser, Safari, Microsoft Edge, Firefox, just click, type in educateafricans.com. It will lead you to here. So let's scroll down so that I can go to mathematics. Like we said, this is our website. We are continuously improving it on a daily basis. If you go there today, you're going to see wonderful things. We are seeing things that are not too good. Today, you see very bad ones. Because our engineers and teachers are constantly working on. So I'm going to click on all courses now so that I can get to mathematics. So today we'll finish indices and logarithm. Those are the two we are looking at today. Indices and logarithm. We'll look at indices first. We'll have time, we'll also look at logarithm today. Okay. So once you click on all courses, you should be able to scroll down and see all the courses. So you can see, yeah, thank you. I'm gonna scroll down and get to mathematics. So this is English language, this is physics, this is chemistry. Okay, you can see this is the mathematics we are using, the one by Precious Lenny. So make sure that you're on that. There are a couple of mathematics files that are on this our site. So make sure you're on the one that we are currently using so that you don't miss out on the assignment. So continue lesson, just register immediately. It's a simple step. So these are the topics. We'll just finish simple interest. That's the last thing we look at. So look at indices, next class, logarithm, sort, set theory, Venn diagram, and the rest. So let's get to indices and click on it. Okay, indices is very, very fundamental in your mathematics. You need to understand indices in order to move on. Abraham, what did they want? Are they waiting? Just tell them. Just 10 minutes out. Okay. So you can see the laws of indices. You can play the video using the screen. So index notation is a method of shortening the product of numbers. Let's say now you have these numbers 2 times 2 times 2 times 2 times 2. How many 2s are you having? You're having 1, 2, 3, 4, 5 2s. So instead of writing a very long 2 times 2 times 2 times 2, simply write 2 to the power 5 because there are 5 2s. Interesting. And that's why you're learning indices. So this is an indicator notation of this very expression. Instead of writing very long 2 times 2 times 2 times 2, and you're going, let's say you have 2 into 100 places, you just write 2 to the power 100. It's as simple as that. So this 2 represents the base, which is what the figure you're talking about, whereas the index represents how many times the base is occurring. So this 2 is occurring 5 times. That's why you have 2 to the power 5. Now let's look at the second example. We have 7 times 7 times 7 times 7 times 7. We have 6 7s. So instead of writing 7 times 7 times 7 times 7, you simply write 7 to the power 6. And this is the index form. This is the indical form. This is the index notation. So the same way you have how many A's? You have 4 A's here. Instead of writing A times A times A times, you say A to the power 4 because that's the same thing. So A is known as the base, whereas 4 is known as the index or the power. So take note, if somebody asks you what's the index of this, index simply means what is on top. The base is the main number that you're counting. Index represents how many times the number is occurring. Okay, so let's look at the laws of indices. What are the laws of indices? Very important. Let's take the first law, very, very simple laws. You need to know them. They are simple. You love them. And with them, that's what you use in solving problems involving indices, the laws. And that's why you need to know all the laws. So let's take, for instance, the first law of indices. And this first law is known as the multiplication law. It simply means that when numbers with equal bases are being multiplied, their power are just added. So let's say now you have 3 to power 2 times 2 to power times 3 to power 5. The bases are the same, 3 and 3. So what you do is that you simply add up the index. Index is 2 and 5. So you say 2 plus 5, 7. So the multiplication of 3 to power 2 by 3 to power 5 is simply 3 to power 7. Even if you do it naturally, you bring them out the way they are. 3 to power 2 is simply 3 times 3. 3 to power 5 is 3 times 3 times 3 times 3. If you multiply everything out, you simply get what you would have gotten if you had done 3 to power 7, which is 3 into 7 places. And in a short form, you simply say a times a to power x times a to power y is simply a to power x plus y. Interesting. So that is the first law of indices, also known as the multiplication law. Now you say, but if two groups of factors, different numbers are multiplied, the different factors are collected as one group to give the product. Okay. So let's say now you have different bases. You have the base here is 2, the base here is 3, the base here is 2, the base here is 3. What you do is that you collect like terms. 2 and 2 are the same, so that you have 2 and 2. 3 and 3 are the same, you have this, so that you can simply add up the exponents for the two bases that are alike. Add up the exponents of the other two bases are alike. So you have 2 to power 8 and 3 to power, this should be 2 plus 4, which is this, 3 to power 6. So take note, this is 3 to power 6 and not 3. Okay, let's move forward. Let's look at the second law, which is called the division law. What does this law state? Division law states that when dividing numbers with equal bases, the power of the divisor is just subtracted from that of the dividend. Very simple. So you can see that they're having the same base, 2 and 2, and you're dividing them. So what you simply do, go to the index and subtract 9 minus 6. 9 minus 6 is 3. So that means 2 to power 3. That is the answer. Very simple as that. So please, this is simply 2 to power 9 minus 8, not 6 minus 6. So take note. So in general form, a to power x divided by a to power y is simply a to power x minus y. So it's just simply subtract the index. So you can see that this is the opposite of the multiplication law. In multiplication law, you add up the index, whereas in division law, you subtract the index for bases that are the same. Take note, the basis has to be the same. Now let's look at the third law, which is the power law. If a number which is raised to a certain power is again raised to another power, it is said to be in power. The two powers are thus multiplied. So let's say you have 2 to power 3 times 2 to power 2. Or you have something like that. Okay, this is a typical example. Please, this is 2 and not 3. This one is 2. Then it's this one that is 3. So if you have something like this, you see, you raise to power 2 times. They're separated with brackets. You simply multiply out the powers. 3 times 2, which is 6. So this becomes 2 to power 6. This is 2 to power 6. So in general, a to power x times y is simply a to power xy. Okay, so let's look at the product power rule. Product power rule. Okay, the product power rule says that when a product of different factors are raised to a certain number, perhaps in a bracket, the power is distributed over the factors. So you have factors A and B here. So once you raise it to power x in brackets, you can distribute it over these bases. So A to power x and B to power x. Now we'll talk about the zero index law. The zero index law simply says that anything to power 0 is equal to 1, even if it is 1 million. 1 million to power 0 is 1. 2,000 to power 0 is 1. 5 to power 0 is 1. 0 to power 0, everything to power 0 is 1. So you can see this. 1,000 to power 0 is 1. 5 to power 0 is 1. So take note. Then we'll talk about fractional index. Fractional index simply states that when you have something like this, n to power sort a, this, that you can take This is not well stated. Okay, this fractional index, I'm gonna write it out. Please, I'm gonna quickly open MS Word or PowerPoint so that I'll write it so that you understand it better. But actually, what is simply states that, let's say you have a to power in the white root of a all to power x. So that's what it's stating. The white root of a all to power x. But I'm gonna let me quickly. Yeah, goodness, you want to ask some question? Let me get your question. So while I wait for goodness question, let me quickly open PowerPoint and state this law very well so that you understand. Okay. So like I told you guys, I'm having a short program. So this class is not going to last long. So once I open this PowerPoint, I'll write an assignment there after explaining the fraction index rule. So it's your duty to solve all the assignments and submit. So where are you going to submit the assignment? You're going to open up this Educate African platform, get to this very topic we learn, indexes. You're going to see the Q&A section there. On the Q&A section, paste your answers there or type in your answers there, okay? That's how you submit this. Okay, so let me quickly open up. I just opened up a notepad for the last law. I just opened up PowerPoint. I hope everybody can see my PowerPoint now. Okay. So quickly, indices, that's what we're learning. Okay. So power fraction law, that's the law I want to explain. So how is this law stated? This law is simply stated like this. Say you have A all to power so you have A all to power X all over Y. That's what you have. So this is all to power. So I'm going to select it and take it as a superscript. Please put yourself on mute. Who is disturbing us? Goodness. Super. Okay. Okay, so say we are having a to power X over Y. So it's the same thing as saying the white power of yeah, how are you? Okay. System is hanging a little bit, but you're gonna solve. A. So it's the same as saying the white power of A, white power of A, all to power X. Okay, let me see. I think there's a one single where I would have done this. Insert equation. Question. Um, okay, the same way. So white power of A, all to power X. I'm gonna pick up the X alone. Control Shift plus. Okay. So this is what the law states, that A to power X over Y, call it the power fraction. So the power is not just X or Y, but it's a fraction X over Y. That this is equivalent to saying the white root of A to power X. So those are the laws of indices. So I'm going to give you an assignment now. Okay. So number one assignment. Number one is going to be supposed to sort out for me A to power 4 times A to power 5. Okay, A to power 4 times A to power 5. So I'm going to quickly Control Shift plus, okay, and this Control Shift plus, okay. So this is the first assignment. So sort this out and tell me what the answer is. Then the second assignment is going to be 3 to power 6 times 9. Okay, 3 to power 6 times 9. So let me know what that is. So 3 to power 6 okay, times 9. Okay, what else do I give you now?